So exponent rules, again, can come into play. We talked a little bit about them when we were doing order of operations, but not real in depth, and we didn't really have anything too crazy going on. But a couple things about exponents can be kind of weird, so we need to make sure we get set here. Exponents, in and of themselves, is a number that's just letting you know how many times to multiply a number by itself. It doesn't mean, like with our example here, 2 to the third power, doesn't mean we're doing 2 times 3. It means that we're doing 2 times 2 times 2. How many times am I going to multiply 2 by itself? And so when we talk about these, the base, and actually I'm going to change that word in just a second here. Because a base doesn't always have to be a number. A base can also be a variable. And so I want to make sure that we keep that clear. We still can multiply a variable by itself several times too. And so 2 to the third would be 2 times 2 times 2. Which would be 8. Okay? So here's the part that gets strange though. And you start to wonder what mathematicians were thinking back when they were first doing this stuff. So the exponent rules get their own set of rules. And they're going to teach us a little bit on how to operate with exponents. So here's the thing. Everything you've ever learned about regular numbers kind of gets thrown out the window when we're doing exponent rules. Because you're like, okay, I got this. Product rule. Product means multiply. So I'm just going to multiply the exponents, right? No. Okay. When we're doing the product rule, we're going to add the exponents. Okay. One other thing I want to mention here, and I'm trying to figure out a good place to put it. We're going to put it right here. Maybe. All right. Your bases have to be, I'm writing right over into other parts. So you're like, okay, so what does that mean? Bases have to be the same, and that's true for all of these. Okay, if you're doing bits and pieces of things. What that means is that number that you're taking to whatever exponent is the same for both. So like here in the example, okay, my base is 2. They're the same. So I can just go ahead and add the exponents together. And I probably, since it's a number, could have gone further. But we're just trying to get the idea down here. If those numbers weren't the same, so I'll just put this on a sticky note because I don't want to confuse people and put it on there. So like if I had 3 squared times 4 to the third, okay, I can't miraculously like multiply these numbers together and then add the, that doesn't work. I'd just have to leave this or get the individual numbers and multiply them together. The only time you can use the rules is when the basis is the same. So let's see here. Quotient rule. Quotients divide. But we're not going to divide. At least not the exponents we're not. We're gonna subtract the exponents. We can kind of see that here. And this rule I'm going to chat a little bit about as we go, because we can make that a little easier too, but I want to get to a specific problem before we do. Same thing. Bases got to be the same. If they are, we can just subtract the exponents. And this one I know off the top of my head, so 3 squared, 3 times 3, not 3 times 2, is going to be 9. So we just got to get through the weirdness here. So you're like, all right, multiply is add, divide is subtract. Can this get any weirder? Oh, it can. It can. The last one we're going to chat here is the power rule. is when we have parentheses and we have two exponents that are working. And whenever that occurs, if I can get my red to work, but it doesn't want to, so we're going back to this. We're going to multiply the exponents. Now here I don't have to worry about the base thing because there's only one base. But what we're going to do is we're going to do 2 times 3. Inside times outside. That is a large number. Do I want to try and do that one off the top of my head? I don't think so. I'll still find the answer though. Oh, that wasn't as big as I thought. But again, my bigger thing here is that we know the rule to get to this more than I do, because I could punch that in the calculator and it would tell me the answer. And so what we start to look at down here, and I won't do all of these because we still got some in the back and I want to get into a little bit of the complexities of these, is chatting more about, okay, I got you, Hardy, you know, we're adding exponents here, I got you, okay. We're subtracting exponents here, I gotcha. We're multiplying exponents here, I gotcha. But then we get a little twist. And the little twist comes, you're like, okay, so now there's coefficients going on here. So do the coefficients play by the same rules as the exponents? No, they don't. They play by their normal rules. So, reminder, and this is where it's nice that I've got some room here because we're going to write this in. Okay. Coefficients. Oh boy, I'll get harassed for this later, but that's okay. Don't play by exponent rules. The English people will get on me for that, but that's okay. I'm not an English teacher. So coefficients, the big numbers, we're not going to add them. We're still going to multiply them like we normally would. Or if we're dividing, we're not going to subtract them. We're going to divide them like we normally would. And now, the only place that's true with, it's going to keep to the rule is the power rule, but we'll get to that when we get there. So here, 3 times 2 is 6, but I'm still adding the exponents on the x's. So I'm actually using 2 different sets of rules within the same problem. That gets a little crazy. So anytime you see the big numbers, just a coefficient, no exponents involved, just do what you normally do. 4 divided by 2 is 2. Why? Be careful. There's still a 1 there. And we get set. But here's the one that gets people the most. I've seen this. I just was doing a test with my Honors Algebra 2 yesterday. They were getting burned by this. It's like, okay. That squared out here, all the stuff that's in the parentheses. Remember, that 5 actually has an exponent on it. Okay, it's a 1. And so here, that squared multiplies to that 1. 1 times 2 is 2. That squared goes to this 8. We multiply the exponents. So there's the one place that it actually does work the same for both. And then, of course, we can figure out what 5 squared is. So we're going to simplify that. So again, coefficients. Don't play by exponent rules. Don't do it. It'll cause problems. Okay? That covers a lot of what we do, but there's some twists to these rules. And that's what we're going to finish up with today. Mathematicians are great at telling you something and then putting a little twist into it and go, wait a minute, where'd that come from? So a couple more rules. So we have the power of a product. We're going to blend the two things together. And we kind of just saw that over here. Any exponent outside is going to go to each piece of what's going on the inside. Sort of like what we just said over here, each of these has an exponent of its own, 1, if we don't see one. And so that exponent is going to go to each of those. So 1 times 5 is 5. 1 times 5 is still 5. Be careful. Okay, these, if I wanted to do the answer on my calculator, okay, I could at this point, but you can't do 2 times 3 and then keep it to the 5th. You can't make that like 6 to the 5th. It doesn't work. I mean, if you want to go in and be like, all right, ooh, geez, that was not what I wanted to do. I mean, if you wanted to get the big old answer, that's cool. But as far as the rules go, it would have to work this way. Because let's say I decided, I'm just going to multiply those and do that to the 5th. Do I get the same thing? Oh, I did. What's up with that? Did Hardy get lucky? We'll find out. We'll find out. Same thing with your quotient. If you're dividing and it's in parentheses, there's a power out here. It goes to the numerator and the denominator. So here, we've got 1 to the second and 4 to the second. And again, when I can take things further, like if it's not going to be some huge number with scientific notation and stuff like that, I'd go ahead and simplify it. But I do want to see that we know what the rule is. But finally, how many rules have we done? Like 5 so far? We finally made it to my favorite one.
The easy one.
The easy one. The 0 rule. I love the 0 rule. Anything to the 0 power is 1. Now, I mean, I love to get crazy with my extra example of this. So we even could say 4x to the 23rd, y to the 17th, z to the negative 316th to the 0 is still 1, okay? It doesn't matter. So be on the lookout for those. We like zeros. It just makes them go away, kind of. No offense to 1. 1, you're still a number, but it just doesn't kind of move the needle at all. So we like those. And then the last one, okay, the negative exponent rule. Now, we don't like negativity. Positivity is such a better thing. So here's how this works. We are going to flip the negativity. Now, if I was going by mathematician language here, I'd say, we're going to take the reciprocal of the, I don't need to get into all that. We're going to take the negative, we're going to flip it. Like, again, and I'm not promoting this, but if any of you have ever dealt with like younger siblings that are just like constantly bothering you and they're being all negative and stuff, if you took them and you said, hey, watch this, and you took them by the legs and they're tipping upside down, they're like, hey, what are you doing? They'll change their tune real quick and they'll become more positive about stuff. Hopefully, we'll see. So, for instance, what I like to do when I see a negative exponent is I think of it as a fraction. Hey, this is a to the negative second over 1. But what am I going to do? I'm going to take that negativity and I'm going to flip it to the other side of the fraction, and that makes it positive. So here, with 5 to the negative third, this needs an attitude adjustment, so we're going to flip the 5 to the third to the bottom. The 1 will stay up top because something's got to stay there. And again, if I want to simplify a little further, I can punch the 5 to the third in the calculator. Hey, Hardy, what would happen if I just put 5 to the negative third? If I just punch that in my calculator, okay, I'd get a decimal. Now, with our cool calculators, we can just hit math, enter, enter, and it would fix it for me. But again, the idea here is to know the rule, because what if I throw variables in? The calculator can't do it. I am going to mention one other thing too. I don't know if you're going to run into it here, but I never want to leave you hanging on something. What would happen if I had a negative exponent in the denominator?
You still flip it, but it will be on the top instead of the bottom.
Bingo.
And then it will be a whole number.
Bingo. It moves to the top. I mean, I could put it over 1, but that's not going to change anything. And 2 to the 4th power, 2 times 2 times 2 times 2, would be 16. It wouldn't be a fraction anymore. So we just got to keep an eye out for some little details. This is a great detail lesson if we're trying to work through some of those things. So let's try to put these to a little bit of use. Again, some of them not going to be too complex. Biggest thing with any time you have power of A, whether it's product or whether it's quotient, is remember it goes to everything in there, not just the thing that's closest to it. And that's the biggest problem that people tend to run into. They're like, all right, Hardy, like what? I got so much confidence in this group, I'm just going to the bottom 4 where crazy's going on. Down here, I got to remind myself, these all have little exponents of 1s, even though I may not see them directly. They're there. And so I'm multiplying exponents. 1 times 3, 1 times 3, 1 times 3. And whenever we get into this situation, like if this is the quiz Friday or something, I would put that in my calculator or do it in my head to get that simplified. But again, I'm going to have to know my rules because I can't put those X's and Y's in the calculator. And so sometimes, holy moly, check out how much of this we're going to have. Okay, I got to do this in different colors. So 2 squared is 4x squared y squared. And then, is this pen working yet? Okay, there we go. That 2 also goes down below to the 3 and the y. But here's where, for the first time, we have to be careful. Every other problem we've done, once we did the problem, we were done. Oh, not this time. Because I'm like, okay, does 4 over 9 get any easier? Math, enter, no, okay. X squared, ooh. We're dividing, I still see y's in multiple places. I shouldn't. 2 minus 2 is 0. Anything to the 0 power is just 1. So they go away. It doesn't mean y to the first. It literally just means 1. I mean, I guess I could write times 1. Wouldn't change anything. So if you ever see that, if you see more than one variable still hanging out at the end, more of the same one more in more than one place, we got to fix that. Best question ever. What's the answer, number 7?
1.
1. That. Don't have to even do the distributing. I see 0, it's 1. Now, this is a little more interesting. You're like, oh.
Multiplying everything by negatives?
Lots of negativity here. We don't like this. We're going to have to fix this. This is not okay.
Put it all over 1 and then flip it.
Yeah, we got all those things that are negative, so they all need to get flipped. So 2 to the 3rd goes to the bottom, x to the 12th. Everybody's happier in the basement here. All right.
Yeah.
Make sure the 1 gets put up top, though, because otherwise they're technically not in the basement, because we don't even have an upper floor if there's nothing there. And we'll clean that up. Now, I normally will have people ask, and I'll take this on. I'll have people say, hey, what would happen if at the very beginning, instead of distributing it, I just took that whole thing and flipped it down to the bottom? Can I make that positive 3? Yeah. I'd get to the same answer. I'd still have to, cube everything, but it just changes things a little. So you have some options there. But that's our overview, okay, of what's going on with all this exponent business that we're doing. So, what we are going to take a stab at here today. I want to take a peek at one thing. Okay, that's what I needed to see. So, over here in the practice, we are taking a peek at pages 7 and 8. Yes, I know, we've had a couple of pages we've skipped. I've done that on purpose. That's coming back. But play with those. I have a physical answer key up front, and I was